Right, good afternoon. Phi size 1 and phi size 3. Okay.
Hi.
Good afternoon, everyone. Okay. So this is, I think, our third lesson. Is it the third or fourth lesson? Third lesson, isn't it? Ping Ya, Ping Hao. This is third lesson, isn't it?
Yes.
Third time I met you all. Yeah? Okay. Uh, First, I just want to explain to you all why I need to change the time. Because now the current Form 5 student in the school one, we were told to split them to two. Now, one class split to two. The Pengarah asked us all the school to split, okay? Because our student here, the attendance is still very high, okay? So every day, basically like 5 science 1, science 2, they have full attendance. Even like today, 5A5, the last class also, only 4 absent. 25 of them out of 29 came. That's why we have no choice that we have to split. Okay, once we split, right, mean the teacher teaching the current Form 5 in the school one, the teaching period become double. Okay, we cannot ask somebody teacher, some other teacher to teach. We have to teach both. So our timetable become double. So it become clash with our these are online class timetable. There are two timetable, okay. These are online class timetable is manually set one, is not using computer one. Only the school current Form 5 student timetable we use computer to set. That's why it will clash, because two system, one is manual, online one. The other one is in the school using the system. So it's like class, we cannot avoid this problem. So very sorry that so I have to change your time. Okay. And also I don't want to miss, because you are in Form 5. Okay. In Form 5 already, I don't want to miss the lesson. Then we cannot finish the syllabus, then it become a big trouble for you all. Okay. They are also not sure when you all can come back, so that's why I try very hard not to miss any lesson. I want to change the time. So for time being now, I change to Wednesday 2 to 3. Okay. If some Wednesday I have meeting in the afternoon, because we have administrator meeting on Wednesday one. Okay. If I have meeting, so I will change to Thursday. I hope you're okay with it. It's either Wednesday 2 to 3 or Thursday 2 to 3. Okay, I won't put on Friday. Okay. So, okay. Okay, now I start the lesson. So I start share the paper with you. So please look at the paper now. Okay, our last lesson, do you see anything or not on the screen? Can see anything or not? Ping Hao can see or not?
N.
Can, okay. Ping Hao, can you tell me our last lesson where we stopped? The leaf, isn't it? Leaf finished already, right?
Yes.
Just finish the leaf, correct?
Yes.
Okay, thank you. Okay, now we go into this one. Resolution of forces. This is a very important topic. Those who absent today, there are few of them absent one that missed the lesson. So I hope they have to catch up themselves if they miss. Okay, what is the meaning of resolution of forces then? Resolution here means we resolve it. Resolve means we break up the force. Why need to break up the force? Because for us, easier for us to do calculation. When you break up the force to certain direction, more convenient for us to calculate. Okay, example you see now. When you have a force F to this direction, when it's in this direction involving angle, right, there's a little bit difficult for us to calculate, So what we need to do is you break up this force to X component and Y component. Please change this is X component, Fx, X component. This is Y component. Okay. So remember, resolution of forces means you break up the force, follow x-axis, y-axis. Understand? So the x-axis we call x component. So Fx. Okay. The other one follow y-axis one is y component. okay, or vertical component, right? Okay, now you see here got cos and sine, isn't it? Okay. The mathematic parts are trigonometric part. I don't want to explain to you lah. I just want you to remember like this. In physics, you just need to know like this. When you are given angle theta here, given angle is here. Here no given angle. So you make use of this angle lah. Okay, the component very near to the angle is cos. You see, is cos. So you take force F times cos theta. So you get this value. So meaning that x component here is you cannot memorize x is f cos theta, y is f sin theta. No, that's wrong. Not every time like that one. It depends where is the angle. The angle given is here. So when the angle is here means this is the cos. So f times cos theta. So you get this value lah. Then the other one not given angle one is automatically become sine. F sine theta. F times sine theta, you get this. Okay. The moment you break up to x component, y component, meaning that this force doesn't exist anymore. No more already. It's already broken. No more. You break them up already. So now you only consider x and y. X and y are easy for us to calculate now. You know why? Because you can take Pythagoras theorem, right? Pythagoras theorem to calculate 90 degree x and y always 90 degree. So you can take Pythagoras theorem to calculate later. Here I think it's wrong. Please change. So this is x. Okay, x component. This is y. Okay, please change. So okay, you know how to break up how to resolve the force to x and y component. In most of the cases, we break up to x and y component. And then which one is cos, which one is sine. So you must be very careful, you must see the angle. When the angle is here, this one close to the angle one is cos. Just remember that. With the angle one is cos, f cos theta. The one no angle given automatically becomes sine, f sine theta. So you just need a calculator to press, find the answer, that's all. So this is a first method of resolution of forces, breaking up the force. Okay, that is another case. You break up the force differently one. Okay, you see here. This diagram, this is a slanting plane here lah. So you have an object here. So the object will have weight. So the weight is going down vertically. So this is a force lah. The weight is a force actually. Okay, so the force is here. Okay. In the case of this like that, right? Follow the slanting surface, right? Of slanting plane. We don't resolve to x and y. No, we don't do that at all. We resolve follow the surface of the slanting plane, this direction. So break the force, this force, the weight is a force. You break it up to this direction, follow the surface. Another one is a 90 degree one. Okay. Why must go this direction and this direction? Because the force is going down. When it's going down, logically, this one must go this direction, cannot go up, isn't it? Must go down. Okay. And this one 90 degrees, so must go here, understand? And second thing, the angle, theta is here. That is something you need to know now. When the angle theta is here, this angle automatically becomes the same. Also, theta is the same one. You look at here. You see here now. If here is 30 degree, right? And you draw a line 90 degrees, you see this angle also 31. Because when here 30, 90, this one 60. When this one 60, here must be 30. You see or not? So always just figure it like that lah. This angle, same as this angle. As I when this is theta, I can put here theta. It's the same one. Now because this component near to this angle given, so this one is cos. So it's W cos theta. So you get here. Since this one is already cos, then this one is sine, W sine theta. Okay. So A is W sine theta, B is W cos theta. Okay. Two different ways to resolve the force. Remember. So One is strictly follow X and Y, okay? When in a special case like this, when you have something on a slanting plane like that, so no point you take X and Y lah, you follow the surface because the object is going to move down like this, right? So follow this surface lah, okay? So resolution now, remember now, where is X, where is Y, you must make your shell very clear. Cannot memorize one, you must memorize. The one very near the angle theta, the one is cos. Okay, the one no angle given becomes sine. Okay, can understand? Janani, do you understand me? Janani, do you understand or not? Nobody answer me. Notice, yes, sir. Okay, she answered already. Okay, thank you. Okay, now we look at example. The example here now. Okay, the first one, this is very direct. Now you see, find the value of px, py, right? X component, y component. You can see lah, angle 50 given here. So here cos lah, 200 times cos 50, right? So you press your calculator, you get this number come out. So 128.5, right? And then here, when this is already cos, definitely this one is sine. So 200 sine 50 degree. Press the calculator, you get this answer. So this is how you find the X component, Y component. Understand? So far, I think no problem for you to understand that if you pay attention, okay? No reason you cannot understand me one if you pay attention, okay? All right, second example. See how you take X and cos and sine. The first is here. The original is here, not force lah, this is speed, 75 meters per second. Now given angle 70 is here, right? So automatically, straight away, this is cos. Okay, 75, whatever unit here, you don't care lah, whether this is force or speed, doesn't matter one. 75 times cos 70, you get here. Press the calculator, you get this answer. Okay, whereas this one, only thing already sure is sine. 75 sine 70. So press the calculator, you get this answer. Wait, understand or not? How do you understand? Ping Hao, understand or not?
Yes.
Tan Eng Seng, understand?
Yes.
Yes, okay. What about this Zhong Jiayin? Understand? Zhong Jiayin?
Yes, understand.
Understand, Zhong Jiayin. And Emily, do you understand? Emily?
Yes, understand.
Understand, Sid Ailing, understand or not? Sid Ailing?
Yes, understand.
Understand, okay. Mok Chui Xian, understand?
Yes, sir.
Mok, understand, okay. I call a few boys, Mu, okay, Mu, do you understand?
Yes, sir.
Mu, your friend here or not?
Yes.
They are here lah. Let me check the name. Are they here or not? They are. All right. Next example. Okay, 7. 7. Okay. Now this question is like the example given just now lah. Figure shows stationary wooden block. Okay, this is a wooden block here. Mass 50 kg. 50 gram. 50 gram immediately change to kilogram, divide 1,000, and then times 10 Newton, you get 0.5. So meaning that the force here, the weight here, 0.5 Newton. This is the one you are going to break up. You are going to resolve it. Okay. But follow this direction, This one follow the surface of the plane. Another one is 90 degree. So here. So now you see what the question asks. What is the magnitude of weight parallel to the inclined plane? I said parallel. Parallel means find this one, no? Not finding this one, find this one. Parallel to the inclined plane. Okay? Okay, now the concept is easy. For angle 40, automatically no need think already. This one 40, same. So this one 40 angle is here. This one become the cos 0.5 times cos 40 is here. So this one become the sine 0.5 sine 40. Since the question asks for parallel to parallel, means we find this one only, no? So the answer is 0.5 sine 40. So you calculate, you get this answer. So very simple, correct not? Then, can you understand? So far, okay, resolution. Later on, there's a lot of questions in the objective, a lot of very difficult questions. You will see how, difficult question. But before that, you need to move into another one first, then only you can answer the question. Okay, next, forces in equilibrium. Also very important concept, forces in equilibrium. Okay, equilibrium means the forces acted in all directions. To the left, to the right, they are same. When the forces are same but opposite direction, they will cancel each other. So it will cause the net force, resultant force becomes 0. So meaning that during forces in equilibrium, right, the net force must be 0, 1. When all the forces are balance up each other, okay, for example, left, right, same, so they cancel out, so becomes 0. Up, down, same, so also cancel out, so becomes 0. So totally, when the forces are in equilibrium, when you total up all the forces, you must get the answer 0. Okay, so when the net force, when the resultant force is 0, means the object is in the state of forces in equilibrium. Understand? Okay, please highlight here. The principle of forces in equilibrium state that when forces act upon an object, the object is said to be in state of equilibrium. Okay, this is more very important now. When the resultant force is 0. Okay, please highlight. When you say the object is in the states of forces in equilibrium, one condition, the resultant force must be 0. Okay, resultant force must be 0, no net force. Okay, and because of that, when no net force, no resultant force, what happens is, when equilibrium is reached, the object is in 2 states. Okay, when resultant force 0, there are 2 possibilities. One is the object not moving, stay stationary. Please highlight. Another one is the object moving, but moving with constant velocity. Okay, so remember that all. So these are the things can happen, when the objects are in the states of forces in equilibrium. It means resultant force 0, total force 0. When no something like no force already lah. When no force means the object will either stay not moving, stay stationary, or it will still move but constant velocity. Okay, no acceleration. Yeah. Wait, understand or not? You understand what I say or not? Let's ask this Michelle Chua. Do you understand, Michelle?
Understand.
Understand, Okay. What about this Nicholas? Do you understand? Nicholas, understand? Nicholas, no sound. No sound there. This another one is who? Emily, the person beside Emily one is Eng. Eng, are you here? Eng? Eng, are you here?
Yes.
Eng, do you understand?
Yes.
Okay, okay, come, we move on. The following parts, this one I just explained, you listen. Based on F equal to MA, and A become F over M, right? Okay, from here you see, based on this formula, you say when equilibrium is achieved, F becomes 0 because resultant force net force 0, right? So when this one is 0, 0 divided by anything also, you get answer 0, means acceleration 0 lah. When acceleration 0 means constant velocity only, right? Object remains stationary or move with constant velocity. Actually, now the concept of forces in equilibrium is obeying the Newton's second law. It's the same. Obeying this law. This law say when force 0, A must be 0. When A 0 means not moving or move with constant velocity. Okay. Okay, now Newton third law. Newton third law, memorize the statement. What Newton third law say? Every action there will be an equal but opposite normal reaction. Please add something here. Can someone help me to type that? To every action, there is an equal but opposite direction reaction. So please add reaction here. Reaction. Let's see whether I can type or not. Insert. I don't want to waste time to type here. In my tuition group one, some students can help me to type one. Anyone can help me to type here or not? Type here. Reaction. To every action, there is an equal but opposite direction reaction. Add the word reaction. So you can see here, when something is placed on the floor, okay, the weight is action. This is action. So at the same time, you have normal reaction. So action and normal reaction same lah. Later on, I will ask you why must be same. Okay, why Newton say something like this? Why he say every action will be an equal but opposite normal reaction? But so far, you cannot see anything. You sit on the floor, you sit on the chair, you don't feel anything push you up, right? You don't feel. But how come they say got normal reaction here? Okay. The reason this Newton say something like this is because when something can stay stationary on the floor, it means the forces must be equal. Equilibrium must be there. So in order to explain the concepts of equilibrium, that's why he said you have weight, then you must have normal reaction. Yeah, like that. But you can prove it, it's proven is correct one. When the two forces same means the object stays stationary on the floor, not moving. Okay. Weight equal to normal reaction. So this thing stays stationary. Please. Okay, first one. Okay, now we go through a few diagrams. You need to learn the names of the forces. When this thing is hanging here, so you have two forces, the weight and the tension in the string. So these two also must be the same. Weight and tension equal. When these two forces are equal means the load will hang stationary, not moving, hanging there quietly. Okay. The third, object floating now, floating on the surface of the water. Also got two forces now. One is a weight, one is a buoyant force, or we sometimes call it upthrust force. Later on, you will learn what is buoyant force. But for now, I just need to tell you that buoyant force is something. When you put something inside the water, there will be a force by the water trying to push the object, prevent the object from sinking. The force produced by the water there actually is called buoyant force or upthrust force. In the case of this, right, the weight and the upthrust force, buoyant force must be the same, balance. So this object stay stationary. Stationary means it will float here quietly, not moving. That is the reason. Okay. Yeah, the two forces, remember now, weight and buoyant force. Okay. Time go very fast. Now, next one. Okay, one moment. Okay, the fourth one is lift. Someone in the lift also got two forces. One is a weight, one is a normal reaction. Okay, and when the lift is moving up or moving down with uniform velocity. Uniform velocity means forces in equilibrium. So weight and normal reaction must be equal. Okay, very simple lah, huh? Okay, next. When object is pulled by a force, you have pulling force, you have friction force, you have normal reaction, you have weight. Now 4 forces, right? Okay, out of these 4 forces, right, the weight equal to the normal reaction. You don't need to know that because the Newton third law already proven is correct one. You just assume this one same as this one. And pulling force same as a friction force. When these two same, so cancel out, becomes 0. These two same also cancel out, becomes 0. So what happens is the object will still move because you pull, sure it will still move, but with uniform velocity, no acceleration. Okay, as we already know just now, right? When forces are in equilibrium, the object either stays stationary or it will move, but with constant velocity. Correct not? Yeah. So these two, I think, okay, you understand. The next one, you look at the aeroplane, go and recognize the names of the 4 forces acting on aeroplane. Weight, this is of course the weight. Then you have lifting force. This one we don't call normal reaction. No, we say lifting, the force to lift the aeroplane up, lifting force. Okay, and then you have the engine thrust. The engine produce a force in front, forward thrust, or sometimes we just call engine thrust. And of course, you have friction, air resistance. So we call it drag, dragging force. So remember the name for aeroplane moving got 4 the weight, lift, engine thrust, and drag. This is drag, okay? So when weight same as lifting force, this one and this same, so balance, right? Another one is when the driving force, the forward thrust, the engine thrust, same as the dragging force, balance lah. So what happens is aeroplane will move, but with constant velocity. You see here? Cannot be the aeroplane stay static one, very funny. Like see aeroplane stay static in the sky, right? Cannot one. So it will, because the engine producing the force, so it will still move, but constant velocity, that's all. Yeah. Okay, G. Now, you look at this car. A moving car also got 4 forces. 1, 2, 3, 4. Please learn the name. Weight, normal reaction. This one is because the car is moving here, so it's engine thrust. So here is resistance, air resistance, or the tire resistance, all here. So what happens is weight, normal reaction, same. Whereas the engine thrust, same as a frictional force. So forces once again in equilibrium. So the object, the car, will move in constant velocity again. Yeah. Okay, now one last diagram, the balloon. Okay. When you study the forces acting on the balloon, this is a hot air balloon, I think something like that lah, huh? Okay, right. Hot air balloon. So you have weight of the load plus the weight of the gas line, you have gas inside, everything now. And also at the same time, you have buoyant force. I see. I mean the buoyant force are not inside the water only, in the air also got something push the balloon go up, make the balloon float. So we call it with the same name, buoyant force. In your syllabus, you will study later in detail how to calculate the buoyant force. Okay? Why someone asked me question? You test, marah dia betul. Okay? Tutup mic kau. Yeah? You test? Okay, understand. Thank you, you test. Okay, So in the case of this balloon, right? So the weight same as a buoyant force, equilibrium now. When equilibrium means the balloon remain stationary in the air, remain stationary. Okay, so you can see so many examples already. When all the forces are in equilibrium, right? The object must either stay stationary or move with constant velocity. That is for sure one. Understand? Yeah. So far can go, you can follow or not? Nicole Chua, okay. So far can follow Nicole.
Yes. Yes.
Can Nicole can she very disciplined one, okay, Nicole. And these are who are Tan Yi Hang, are you there? Tan Yi Hang?
Yes, sir.
Can follow the lesson or not? Tan Yi Hang?
Can.
Okay, come. Then we move on. Okay, next is two forces in equilibrium. This one no need. We just see the example. Can already. You see the calculation is very simple. Understand it? 2 kilogram. So immediately you have weight, then you have normal reaction. So what happens is, what is the weight? So weight use a formula W equal to mg to calculate lah. Last week you learned this, right? W equal to mg, mass 2, gravity 10, so you get 20 Newton, that's all. Okay, the second one, normal reaction R. So you know that R must equal to W, must be balanced because the object not moving. So the two forces must be same. R equal to W, straight away copy, paste here, 20 Newton, that's all. Solve already, right? Okay, I think this one okay now. The next one, this one is more important. Many students will confuse later on. Okay, you all listen properly. Listen properly here. Okay, three forces in equilibrium. This section is to check or to confirm the forces are in equilibrium or not. You see here, there are three forces here, P, Q, R, different direction. Now we want to know the three forces are actually they are in equilibrium or not. Okay, so to check is like this, you join the three forces to form a triangle in one direction. I say it again. You must join up the three lines to form a triangle in one direction. Okay, you see here. Q, I put it here. P here. Never change the direction. No, still the same. Q is here. P is here. P direction still same. Okay, then R direction also same. No, so you see that Q, P, R. Then you can join them up so to make a triangle in one direction, anti-clockwise direction. So when you can do like this, means the three forces are in equilibrium. If they are in equilibrium, then only you can do like that. Another method is you join like this now. You see, I put here P, I put here. Then join with Q. Q is here, so and R is here. No, you see, P, Q, R also in one direction, but now it's clockwise direction. So both are correct. If you can join the three forces to form one triangle in one direction, either anti-clockwise or clockwise, it proven that the three forces are in equilibrium. Remember now, this is not finding resultant force. It's checking whether the forces are in equilibrium or not. So you try to join them up, see whether can form triangle in one direction or not. Okay, now you see here, when three forces in equilibrium, the triangle of forces is in one direction. So meaning that when the three forces are in equilibrium, so the triangle must join up in one direction. Okay, not the single one direction is. Okay, I know some of you laugh already, say one direction. I also listen to one direction. But I think now break up already, the group no more. Can understand? Okay, some will ask, okay, I want you to, I don't want you all to confuse. When you join up this triangle in one direction, this is just for us to check whether the forces are equilibrium or not related to calculating the resultant force like this one. I think it's here. You learn this, right? Here. You see this one. For this is not equilibrium at all. For this example, is you find the resultant force. You have 10 kilonewton followed by 6 kilonewton, right? So you want to find the resultant force, so you join them up. Join up starting point to the ending point. Direction is from here to here. This is the directions of the resultant force. So this is not equilibrium, understand? This is calculating the resultant force. This one no need follow one direction, so remember that. No, hey, please don't confuse. This one not follow the rules of one direction one. Calculating resultant force must take from starting point to ending point one. Not in one direction one, okay? So clear now? Make sure you clear about it. Wang Yuhan, do you understand? Wang Yuhan. Wang Yuhan, what is very quiet, never say anything one. Hao Hanzi, two of them, like brother, never talk anything one. Hao Hanzi. Wang Yuhan just say yes. Wang, you don't have a mic. How also same. That's why I say both of them are brother. Yes. So what sing one direction song? Oh, you test sing now. Can you sing a song? You test. I know you know how to sing. You test. I love one direction song a lot. Okay. And the other one is Westlife. Okay, I love their song very much. But I think both groups are no more, right? Yeah. Right. Where is it already just now? Okay, here. Okay, we come back here. Another 15 minutes more. Okay, we go very fast. So this one settled already. All right, this one is for us to check the forces in equilibrium. Okay. Now, example. How to solve the problem? Now you see the problem already. You have to apply everything you learned just now to solve one question. Okay. Okay, look at here. One. Tomorrow. You are the class. Lepas 9 dah habis lah. Okay. You just need go to the office, you write your name in the book. Tak ada. Kalau you bagi tahu saya tak buat. Ya, tahu. So buat di Meyong pun pergi besok. Okay. Okay, come back to this question. The following figure show a steel spear 12 kilogram. Okay, 12 kilo means straight away you write 120. This force is going down. Okay, 120 Newton. Okay, and the question is something like this. By using a string, you pull it here. You put it here so that the load is sustained, hanging there. Okay. Hanging, not moving, because he said, pull to the side by horizontal force, the tension, there will be tension. Now, of course, you pull like that, will be a tension in the string, isn't it? So now there are three forces here, you can see. One is a weight, W. One is a pulling force M. Another one is a tension in the string. Tension is also a force. So 1, 2, 3. I say now, these three forces must be in equilibrium. Why? Why I can say that? Why I can say the three forces are in equilibrium? The W, the M pulling force, and the tension. Why they must be equilibrium? Why? Oh, can you tell me why? They are in equilibrium, Nicole Chua.
So
Huh,
that
Nicole?
the sphere can remain stationary.
Ah, yes, correct. Because in the situation like this, right, the sphere, the ball not moving. We want the ball to stay stationary. Not moving means condition is the three forces must in equilibrium. That's why I can say in equilibrium. If the ball still moving like that, at no point you calculate lah. Cannot calculate anything lah because the ball still moving. How you calculate? Right? Cannot. Okay. Now the question: draw triangle of forces. Okay. The answer is here. So I put it like that, lor. W going down. Pulling force M here. And the tension here, you see, ngam here, one direction. Okay, join up in one direction. It's anti-clockwise direction now here. Okay. So it's already proven the three forces are in equilibrium. 30 degrees here now. Okay. So this is the answer for the first one. Okay, the one more important is now calculating of these calculations of the value M and the N, the two. And that is something you need to learn now, okay? Because later on, you need to answer a lot of questions like that. Okay, I go very slow, one by one, you all listen. Okay, now to find the values of M and N, right? You must apply resolution of forces. Break the force. Okay, which force you need to break like this. The one already follow Y, follow X, you don't need to break anymore. Just leave it alone. Okay, like this one, horizontal follow X already. So no need break. This one follow Y, vertical also no need break anymore. Only this one you need to resolve because this one not follow X, not follow Y. So you break up the force to X and Y. And now you see X is to here, because the force is over here to the left side. So your X component must go to the left. And your Y component must go up. Then only logic, understand? Because the force is going here. So your X is here, Y is here. Okay? So only this force need to be resolved to X and Y. Okay, now, since given angle here 30, this one 30, this one I think you all know one, this angle 30, when the angle is here, so this one automatically become cos. And cos 30, so it's here. When this is cos, definitely this one will become sine. And sine 30, okay? Right? So now you have 4 already now. The moment you break up to vertical, this one and cos 30, and this one x and sine 30, actually this one no more already. Actually, you don't need to look at it anymore. No more. Now you take 1, 2, 3, 4. Use the opposite pair to solve. Okay, first, I want to find, I think find n easier, find n. And because n cos 30 going up must same as 120. Going up, going down must be the same. Correct not? Balance, so n cos 30 equal to 120. And then you solve the equation, so you get this answer. Straight away, use a calculator, get the answer. Okay, that is how you use the technique you have just learned, resolution of forces, forces in equilibrium to solve the problem. Understand? This is a final thing you are going to learn, learn how to use it to apply to solve problem. Okay. After that, you find the values of M. To find M, of course, you take right equal to the left law. They must be same because they are balanced. Balance will mean they are same. Here. Okay, class who on dia sudah daftar, maksudnya dia kena buat itu barang. Buat tu di bawah. Kalau pergi PPD, dia kata dia memohon diri Sabah kan PPD akan urus. PPD buat surat, dia akan pergi PPD. Buat. Tapi dalam sistem nanti you klik lah dia keluar. Nah, dia keluar kan okey lah. Kalau dia dah keluar okey lah. Sama macam yang pergi sekolah agama punya tu. Kan diklik gitu. Tapi sekarang tetap boleh klik kan. Dah tutup. Nah. Sekarang dia boleh pergi Sabah kan. Okay, sama. Okay, 4 size 1. Come back. Okay, now to find M, right? So we take the left and the right must be same one. The concept is like this one. Left, right, same. Upward, downward, same. Okay? So M equal to N sine 30. Substitute the N. So press calculator, you get the answer. Okay, I think you can understand this example. This example is very important for you to answer SPM question. Class 4 size 5 size 1, 5 size 3. We've been told that in your SPM physics, there will be 29% of the marks calculation. 29 marks out of 100 is calculation, you know. I mean, you can expect in your SPM paper, we will have a lot of calculation. Okay, like this. Calculation will be a lot. More calculation now. Yeah. All right, next one, our tutorial, we answer the question. Okay, we still got a few minutes. First question, what answer? Can you all try? Okay, tell me the answer. Which of the following acted on by a pair of force? Which one will accelerate? Michelle Chua, which one will accelerate?
D.
Can you explain why, Michelle? Why D? Why D? Michelle?
Because it's not equilibrium.
Yes, correct. Not equilibrium means got net force, got extra, got resultant force. When you have net force, definitely you have acceleration, right? Okay, the rest all balance one. Balance cancel all zero. When zero means no acceleration, Okay, number 2. What is the answer? Figure shows a force F1 here, F2, exerted on a wooden block. The friction between the blocks and the table is 2 Newton. Friction. There is friction, you know. Okay, but we don't know which direction now because we don't know F1, F2, which one is bigger, right? Okay, but now the question asks, which pair of forces causes the wooden block to move with acceleration? Now you have to see, you have to see which one, two pair of forces will cause acceleration. So which one is the answer? Huh? Ho Wan Yin, come out. Ho Wan Yin, where are you?
Yes, sir.
I know you are hiding behind there. Okay, come out now. Ho Wan Yin, any idea or not? Which one is the answer? Huh?
E. Ah.
Yes, correct. Why you say A? How you guess E one? Ho Wan Yin? Correct. Your answer is correct. But how you come to that conclusion?
Because if the
Huh?
F2 I plus 2, then it's still smaller than 4.
Still smaller than 4. Then?
So
So
the
but
F1
you
will
have,
be bigger, and then the wooden block can move.
oh, okay. I understand what you see. Huh? Okay lah. Actually, what she say, I can understand lah. It's correct. Okay, but actually, you just need to think like this lah. The difference between 4 and 1, they are in opposite direction, right? The difference is 3. The 3 is bigger than the friction. Friction is 2. So mean you have net force. Difference between 4 and 1 is 3. Then 3 you have to minus the friction, but the friction is there, right? So minus the friction, you still got extra 1. So meaning that you have net force. When you have net force, then it will move with acceleration. The rest don't have, you see. 5, 7, you get 2. 2 minus 2, 0. Right? This one, 5 minus 3, also 2. 2 minus friction, 2, also 0. When 0 means no net force. So cannot accelerate. Okay, huh? All right, we go one more. Okay. Yeah. Then number 3. This one I think you just see the formula, see the answer, you can understand now. F equal to ma. Force is 8, mass 0.2, A, okay, 4 lah. Okay, 40, this one okay lah. Okay, number 4. Also, you can see to get the answer. 2 kilogram, here 15 Newton. Friction is 3 Newton. Net force is 15 minus 3. But when you apply this formula, net force F equal ma. Net force is 15 minus 3. You find the extra force. M is 2. So A, you calculate, you get 6 lah. So the answer is 6. Okay, Okay, number 5. Number 5, how? Box with a mass 3 kilo push along the rough surface with the force 10 Newton. You push with the force 10, and the acceleration is 3. I got acceleration already. So meaning that the friction is less than 10. Because you apply 10, you can bigger than the friction already. Then you got acceleration. So now what is the friction force? So solution is like that. Net force F equal to ma. So net force, I take the pushing force or the pulling force minus the friction. As I told you just now, right? Because the object is accelerating, meaning that the pushing force must be bigger than the friction. So the net force is you take 10, the bigger one minus the smaller one. And A is 3. So solve the equation, you get the friction equal to 1 Newton. Okay? Yeah? All right. I think I stop here. I know you're very tired. Since early in the morning track until now. Okay? Okay, like this. The rest of the questions, I want you all to try, use pencil, try to find the answer. Okay? Do a little bit of homework now. The rest of the question, try at home. Okay? You all don't go anywhere. Stay home only. Don't go out already, Don't go out. Just stay home. Study, sleep, eat. That's all. 3 things only you do at home now. Study, attend online class. You eat, then you sleep. Understand 啊？你 control 啊 ？Understand？
Yes.
Okay 啦嚇。All right. Hold on, I need to take a pictures first. I forgot already. I need to take pictures. One moment. Because a reflection. Okay. So any question you all want to ask? Any question to ask or not? Anything? Tiêu you he? Any question?
No, sir.
No, sir. Okay. Aventa, any question?
No, sir.
Mitnish, any question?
No, sir.
Mitnish, where's your friend Dennis? I never see him one. Dennis,
Uh,
he's around or not?
I
Dennis,
think so.
I never see his name.
Yes, sir.
Are you here, Dennis?
Yes, sir. Yes, sir.
Okay, okay. What's your name there? I never see your name. Oh, it's on the second page. Okay, yeah, I saw already. Okay, class, okay. You all go to have a nice nap. Maybe I know you are very tired. Those who never eat, go and take your lunch now. Okay, our next lesson is on next Monday. Is it correct? Is it Monday? How is it Monday?
Yes.
Next Monday. So I see you on next Monday. Okay, bye-bye, class. Okay, bye-bye. Bye-bye, everyone.
Thank you, sir.
Okay, bye-bye.
Thank you, sir.
Anyone never
Sir.
haven't sent your attendance or send now, okay? Before I stop recording. The moment I stop recording, so cannot see already.
Thank you, sir.
Okay, bye-bye, everyone.
Thank you, sir.
Okay, bye-bye.
Thank you, sir.
Bye-bye, okay, bye-bye.